In this video, we're going to talk about motion graphing, and luckily for us, there are only 3 different situations. In situation number 1, we have no acceleration. So if we look at a time versus acceleration graph, the acceleration is 0 the whole time, right? Easy. Now, if we think about what will the velocity versus time graph look like in situation number 1, so there's no acceleration, which means we have a constant velocity, which means our velocity stays the same. So let's just pick a velocity. I'll say it's 2 meters per second. Right, so if my velocity is 2 meters per second, the graph will look like this. And we're not accelerating, so the line is not moving up or down. So 2 meters per second, right? We're at 2 meters per second the whole time because we're not accelerating. If we look at what our position versus time graph will look like, well, let's think about what 2 meters per second means. 2 meters per second. That means every second you go 2 meters. Every second you go 2 meters. Every second I go 2 meters. And you can see that now if I act like I drew these to scale and I made a straight line, hold on, more or less, okay, more or less, right? This is what my graph would look like. And the cool thing now is if you just saw what I did, I said, okay, I said for every second go up 2 meters. Every second go up 2 meters. So I can have a constant velocity. If we think about what slope means, slope is rise over run, right? So it's whatever's up here, the change in whatever's up here divided by the change in whatever you have here. So our rise is x, change in position, and our run is time. So you can see that the slope of this line is delta x over delta t. We already have a name for that. It's called velocity. So you can see that the slope of our line in an x versus t graph is our velocity. Right? So the slope of this line is 2, and our velocity is 2 meters per second. Let's look at situation number 2, positive acceleration, right? So it's 1 meter per second squared. What will our velocity graph look like? Well, let's say we started with velocity of 2 meters per second, like the last one, but now we have an acceleration of 1 meter per second squared. That means every second go up 1 meter per second. Every second go up 1 meter per second, right? And again, you can imagine I could keep doing that, but what I'll get is a straight line. But now this graph is saying that my velocity changes as time goes on, right? As time goes on, my velocity increases. That makes sense. It's a positive acceleration. And again, if we think about what the slope is in this circumstance, what's your rise? V, so your change in V over your change in T is your slope. But guess what? We already have a name for that. The slope is acceleration, right? The slope of this line is 1, and the acceleration on this is 1 meter per second squared. So what will our x graph look like, x versus t? So in this graph, our velocity is increasing the whole time. Okay, so I'm not going to draw this one to scale. I'm just going to make a liney line out of this. It's going to look something like, well, that was ugly, but something like that. And here's the cool thing, right? Before we said that in the x versus t graph, our slope is what? Our slope is velocity. And you'll see that we don't have a constant slope here, right? This doesn't have one slope to it. In fact, the slope is changing, right? The slope here, that's kind of where the line is going. The slope here is kind of like there, slope here like there. So you can see it's getting steeper as we go up, which means the slope is getting higher, which means our velocity is getting higher. That should make sense. And on our last graph, negative acceleration, so say it's negative 1 meters per second, and let's say we started at like, I don't know, let's say we started at 4 meters per second. Well, this is saying every second, subtract 1 meter per second. Every second, subtract 1 meter per second. So we wouldn't be able to keep this up very long, but you could see that our graph would look like this. And if we're really good, we could get going backwards if we really needed to. You don't have to worry if you didn't understand that last bit. And again, the slope here is equal to our acceleration. The slope is now negative 1 because our acceleration is negative 1 meters per second squared. And lastly, what will our x graph look like? Well, you see that we're going forward still for a while, but our velocity is getting smaller and smaller, which means the slope should get smaller and smaller. And that graph looks like this.